Cylindricity and circularity. We spoke about the flatness tolerance, which is the difference between two parallel planes, and that the surface has to lie between these two planes. But what if my surface is not a flat surface? What if I want to tolerate a cylinder? In this case, we will have to use the cylindricity tolerance, so my object looks like this. It's a cylinder, and I want to say, I have two cylinders. The distance between these two ideal cylinders is, for example, 0.1, and the real cylinder that I'm tolerating has to lie between these two cylinders. It's just like the flatness tolerance, but instead of two flat planes, we use two cylinders between which the surface has to lie. So any point on the measured cylinder has to lie between these two cylinders. And the way that we do this is by adding a leader in the drawing perspective, pointing at the surface that I want to tolerate. And the feature control frame should say, I want this surface to be cylindrical. So I use the cylindricity symbol, which looks like this, and then I put my tolerance zone in the frame. So in that case, there will be two cylinders. The distance between them is 0.1, and my surface has to lie between them. Well, if my object is a cone, and I want it to be a cone, I cannot use the cylindricity tolerance for it. What I can do is use another tolerance, which is called circularity. The circularity says that I will cut this cone or the element that I'm tolerating at a specific plane. And the projection of my surface, or the intersection of my surface with the cutting plane, has to be circular. So here, it'll be a bigger circle. It does not matter as long as these different circles are circular in shape. So in circularity, my 2 zone, the 0.1, is a distance between the two circles, not two cylinders. Of course, for a cylinder, you can still use the circularity tolerance, but in this case, you will not be tolerating the whole cylindrical surface of the cylinder, but you're just tolerating it at one cutting plane. If you don't specify your cutting plane, the circularity tolerance is valid for any cutting plane along the cylinder, but any of these cutting planes will be treated separately from the other one. This means I will cut here and cut here. And here the circularity has to be between these two circles. And here the circularity has to be between these two circles. But I cannot add a relation between the different cutting sections. I did not add a relation between these different planes. So in this case, the cylindricity tolerance will work better than the circularity. So, here is a real-life example. How can we tolerate this part? It has a cylindrical segment and a cone element attached to it, and also a short cylindrical segment. So, we have a long cylinder, short cylinder, and they're connected by this cone. Normally, you would use for the long cylinder the cylindricity tolerance, and for the conical part, you would use circularity tolerance, and for the short cylinder, you will also use a circularity tolerance. Of course, you can use the cylindricity tolerance for the short cylinder, but it just does not make sense in reality, because when the element is just too small that it cannot even deviate in such a short length, and there is not enough length to measure different cross-sections. But as I said, theoretically, you could also here use the cylindricity tolerance. Common mistakes. A common mistake is where you think you're pointing at a cylinder. A cylinder has a diameter, so you add here a diameter sign signaling that you're tolerating a cylinder. This is completely wrong. You have to avoid this because here the tolerance zone is the distance between the two cylinders. It's not the diameter of a cylinder, it's the distance between two cylinders. So you cannot add here a diameter sign. So always, for cylindricity, you just add the tolerance without a diameter sign. Another common mistake is where you point at the dimension with the leader. This way you're tolerating the center line of a cylinder, and you say, I want it to be round or cylindrical. A center line is just a line. it cannot be cylindrical. So if you want to continue here and do all the common mistakes, we will add a reference and add here a diameter sign to our tolerance. So here you made all 3 mistakes. First mistake is tolerating the center line. Second mistake is the diameter sign. And the third mistake is choosing a reference element for the circularity or the cylindricity. A circle can be round, but not with reference to anything else. So you have to delete the datum. You have to delete the diameter sign, and you have to point directly at the element and not at the symmetry axis.
If you found this video helpful, don't forget to give it a like and drop a comment below. We'd love to hear your thoughts or questions. And if you're into leveling up your skills with expert-led content, hit that subscribe button and turn on notifications. For full courses, downloadable assignments, and certifications, head over to excetify.com. Start learning smarter today.